I'm Anil Kumar. Welcome to my series on vectors. Here is an excellent question from IIT JEE Joint Entrance Examination on vectors. The question here is, if A cross B equals to B cross C equals to C cross A, then find A, B, C for these distinct non-zero vectors. 4 choices are given to you. Now, you're not supposed to just answer them in a minute or so. You need to show your work. These are kind of open questions, open response questions, where you're given multiple choice also. So let us see how to solve such a question. So when I say that A cross B is equal to B cross C, then I could actually bring them together and rewrite this as A cross B minus B cross C is equal to 0. We can actually write this as reverse order, then the sign will change. So we have A cross B plus C cross B as equal to 0. Now this is a 0 vector where cross product is always a vector which is normal to both the vectors, correct? Now, so here you can apply the property of associative law, which could work here. So we get A plus C cross B equals to 0. So that's what we could get, right? Sorry, see this is C. Let me rewrite. So we have A plus C cross B equals to 0. So we get this. Now when the cross product is 0, it means what? Cross product 0 means that they are parallel vectors, right? So that means they are parallel vectors. Okay. So that means I could now write A plus C as some scalar multiple of B, right? So let's say K. So K times vector B, since they are parallel, right? Let me write down the cross product formula right in the beginning. So when you are saying A cross B, it really means magnitude of A times magnitude of B times the angle between them, which is sine theta. So that could be 0 for a non-zero vector if theta is 0. That means angle between them is 0. They are collinear, they are parallel. Is okay? So that means the sum of these two vectors is parallel to the vector B. So we could write this as a scalar multiple since they are parallel, right? So that means scalar multiple. Correct? Okay. So we could do the same thing with the other two sets of vectors. So if I take up, let us say, A cross B and C cross A, they're also the same, right? So A cross B is equal to C cross A. So that means A cross B minus C cross A equals to 0. So A cross B plus A cross C equals to 0. That means A cross B plus C equals to 0. That means A is a scalar multiple of B plus C. So we can write A as equals to, let's say, scalar multiple L times B plus C. Or better, since we wrote this as the sum as parallel to this, we'll rather write B plus C is equals to L times the vector A, right? So where L is a scalar multiple, correct? Similarly, if you do the same operation on the other two, what do you get? Following the same pattern, so we have here B cross C is equal to C cross A. That is not really required, but okay, let's just do it. So B cross C minus C cross A equals to 0. So we could now write this as B cross C plus C A cross C equals to 0. So we get B plus A cross C equals to 0. Now this 0 is a vector, okay? So that really means that this sum B plus A is equal to some scalar KL, let's say M, times the vector C. Correct? So we'll end up into understanding that sum of any two vector is basically scalar multiple of the third vector. Correct? That's what we'll end up with. Now, we could actually find the value of A from one of these. Let's say this is 3 for us. Okay, let's say this is 2 for us, 1 for us. So if I use these two equations, A plus C equals to KB and B plus A equals to MC, then we can find a relation between M and K, right? Okay, so let's figure this out. So what I'm trying to say here is that if I combine the equation A plus C equals to K times vector B, right? And if I take away, then I get that A and A cancel. So we get B plus C, B minus C. We are doing takeaway. Vector B minus vector C is equal to M times vector C minus K times vector B. Right? So that also means that bringing them together, we could write this as B plus KB equals to C plus MC. Right? Or vector B, 1 plus K, the scalar multiple, and taking C common, 1 plus M, they are equal. Now, since B and C are distinct, they are not equal, the only possibility could be that 1 plus K is equal to 1 plus M, right? So that gives us a possibility of 1 plus K equals to 1 plus M. And that could be possible if I could make K equals to M equals to minus 1. So both become 0. So that could be one way of doing it, right? So definitely we get K equals to minus 1 from this particular expression. Now, if I use K as minus 1 in my first expression, which is A plus C, combination of these two vectors, is minus 1 times vector B, then bringing it together, I get vector A plus vector B plus vector C as equal to 0, right? 0 vector, of course. So that gives me the result of what should be A plus B plus C. So the answer here is C. You get the idea, right? So that is how we could actually prove that the result is 0. Now there are other thoughts which could be utilized to answer this question. Now if you really want to do it in less than a minute, right, then you could do some strategic thinking about it, right? You could have a situation where these cross products are exactly same. So the situation could be, it reminds you of an equilateral triangle. Let's say we have one vector here, the other vector, and the third vector. Now, what is the angle between these vectors? So when you look at the angle, it is the angle 120 degrees, right? So and if we assume that these are of the same magnitude, right? So magnitude could be same, direction is different. In that case, what is the sum of this? So when you add them up, it is 0. Correct? And when you do a cross product, since it is going in the direction shown like this, so they are all pointing upwards, coming up, right, normal to this page, and their magnitudes will be same. Correct? So you could think about this to quickly answer this question. So that is one way. But if it is an open response question, then you may have to show all the work which we did here. So I hope that makes sense. And this trick works. So I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.